Hey guys, my name is Will Buchanan, and this is Lab 1 involving charge tape. So, a quick introduction. The purpose of this lab is to understand why two pieces of tape interact the way they do after they're given a specific charge. The concepts we can use to explain this involve Newton's second law and mainly Coulomb's law. Glowscript is used to model this interaction and provide mathematical proof to the tape interactions. The result achieved is that the tapes repel each other because they have the same positive charge. And some quick laws to know include Coulomb's law right here and Newton's second law, which includes gravity on Earth. Coulomb's law is the main important one because that explains the electrical force. The initial conditions, our system is tape B, the surrounding is tape A and Earth and everything else around it. And the tape length is 0.2 meters or about 8 inches. And then the tape weight is 0.0002 kilograms. And we're assuming no other forces or external factors are present. And in the experiment, the distance between the two pieces of tape at which the tapes repelled each other was 0.027 meters, or just over an inch. And here's the procedure right here of the experiment I conducted. Let me move this, you can see that. And the experiment questions, if U-tape is positively charged, how should it interact with a charged pen? It should attract the pen. And if the tape is negatively charged, how would it interact with the pen? It would repel the pen. And how would a neutral U-tape interact with a charged plastic pen? It would attract the pen. And the experiment questions, the net Y component on the force on tape B equals 0 because tape isn't moving up or down. And this is because the Earth exerts a downward force on tape B down, but the charge of tape A, the positive charge, repels tape B up with an equal force. And the deficit of electrons equals 7.88 times 10 to the 10th. And this was found by dividing this number right here by the charge of 1 electron to give us the total count of electrons. So on this slide, we talk about what to do with the results. And using Coulomb's law and Newton's second law, we can find the charge of each piece of tape. And since we know the gravitational force is equal to the electrical force because the pieces of tape are not moving, we can find the gravitational force using the mass of the tape and gravity constant, then use that as our value for the total electrical charge. And then we can solve for Q using the Coulomb's law seen here. And once we solve for Q, that gives us the charge of each piece of tape, Q1 and Q2. And we're assuming the charges are equal on each piece of tape, which is pretty reasonable, but maybe not entirely accurate. And here's my code. It's not that much. It has this though. The charge of pieces of tape is 1.26 times 10 to the negative 8th, which is good because it agrees with our experiment. And here we can see the downwards gravity vector and the upwards electrical charge vector. And questions, if the electrons had a positive charge and protons had a negative charge, what would change about this experiment? Nothing in the experiment would change, although it would affect a whole lot of other things, but nothing in the experiment would change because the tapes would still be negatively charged and they would still repel each other because just like two positive things repel each other, two negative things repel each other. And it's important to handle the charged tapes as little as possible because when you're handling and messing around with the tape, the electrons are jumping over from the tape to your hand and causing the charge to be lost. And you don't want this because you want the tapes to be charged up so that when they interact, they display this charge and repulsion force. And if you interact with the tape too much, it could lose its charge and nothing will happen in your experiment, which is what you do not want. Sources of error, a massive tape is a pretty big approximation. We're just using the length and assuming that like a meter is about a gram, which maybe isn't the most accurate way. And the charges were treated like a point charge, which is just the best we can do with our physics knowledge. And the charges are dissipated and altered, as I just talked about, when you're handling the tape and transitioning it from the table to the books. Thanks for watching. Bye-bye.